Okay, I don't know how much time I've got before I have to go, but we'll get started on this right away. It's running at 1.5 times speed. We're dealing with conditionals, and this is just the lecture portion of it. Uh, I didn't realize what was going on with everything, so I am going to. Oh, that's better. I'm going to make sure that I get do the lecture, go through the lecture notes and the actual problem sets in another video. Maybe yeah, in another video. All right, let's get started.
All right, this is CS50's Introduction to Programming in Python. My name is David Nalen, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and other languages are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead. They allow you to take proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly mathematical questions, but we'll start there, only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. The second symbol might not look too familiar because we usually write it all as one thing on a piece of paper, but on a keyboard, if you want to say greater than or equal to, you use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality, it represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things, left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the question using these symbols or any others, we're going to need another keyword in Python, and that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py. The goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare, in which we'll start to express some of this fun. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function, and pass to the int function the return value of the input function, asking the user a question like what's x question mark. Done in the past. Let's do this one more time with y, asking the user for the value of y, and again converting that ultimately to an int as well. So with this one in the story, we have two variables, x and y, each of which have values. And ideally, we should be able to have parity values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print this much out. Quote unquote, x is less than y. So this is a very literally just stating the obvious based on the math, but it's
Let's just take a moment. Let's see if it'll. Oh, it will do it. Oh. Oh, shortcuts. Yay. If x greater than y. For fuck's sake, I'm gonna have to do double quotes every single time. Three. Oops. I need that space.
use some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. yes or no answer, or technically a true or false answer. And that's nice because if there's only two possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They're not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. So let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good I here. I don't want to assign y to x. If x equals y, how I express equality. Let's go ahead and print out x is equal to y. So I now have three conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run python compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y. Exactly as I would expect there. Well, what just happened, though?
Perfect. Okay, good.
In code. Well, let's take a look perhaps at this same code visually, especially if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flowchart. It's a diagram of this program's logic, and more technically it shows the program's control flow. That is the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flowchart, and you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape, and inside of that diamond is a question, Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y. So of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, we don't print anything this time. That's why we only saw 1 print out on the screen. Now there's still a third question, and this flowchart captures that as well. The third diamond asks, x equals y. Now that too has a false answer. In this case, it's 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answers the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code to be directly correct. You want to pretend longer, more sophisticated, more complicated. What would be well designed to do?
So what we would want from JavaScript is to break this as soon as one of the conditions are met, so it doesn't run the other 2 lines of code. Whether or not he's going to go to that point or not, I don't know. We'll find out in a second, I guess.
Thoughts on in what way this program is arguably not well designed, even though it's correct. Let's see here. Khalid, am I saying that right? Your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this. if this, and yet logically I should know the answer to some of those later questions once I figure one out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond, so I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, L if x greater than y, L if x equals y. So I'm going to implicitly...
Okay. Okay. Yep.
Just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program, and I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program, and honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs, but it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what, even if I already figured out what I want to print on the screen, this new version of the program that has if, elif, might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here, but let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow, down marked true, we print out quote unquote x is less than y, but then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say the answer to the first question is now false, but the answer to the second question is now true, because of course 2 is greater than 1. Well, let's go back to the diagram, same as before. We start at the very top where it says start. The very first question up here now, x less than y, is an answer of false, because no, 2 is not less than 1, so we follow this arrow to the next question, this time. Is x greater than y? Well, yes, 2 is greater than 1, so now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask 1 question, and boom, we're done. This time, we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code, and pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined, but logically, we shouldn't actually be getting there anyway, because it's got to be less than, or greater than, or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here, or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
A good question. And yes, so that's going to be my third and final approach, and if you don't mind, let's pivot there right away, identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better, and that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, L if x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the two conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty
Right.
comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first two scenarios, logically, it's got to be the case that x must equal y. If it wasn't the case, that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here, and instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else.
Yeah, that makes sense.
Just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. Still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1, and it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, L if in place.
Now we only have
something like
two.
this. And notice that again, we might have asked one question, or two, or worst case, 3 whole questions. But we can do better than that. Using else as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less
Oh,
you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here, and let's propose how we might ask a couple of questions at once this time, perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine, is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y, or x is greater than y, let's go ahead and print out x is...
so if x is greater than y, or x is less than y,
not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use Hope's else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y, or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. Okay, x is not equal to y. Let's do it again. But 2 for x, 1 for y, x is not equal to y. And one third time, how about x is 1 and y is 1, x is now equal to y. Now, if we want to compare that visually too, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false, so we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code, and then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that too, I think, is going to work exactly the same, but the picture now looks a little bit different. Notice that this was our flowchart earlier that represented that same logic, and there's a bit of complexity. You got to go left, you got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question, is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you, we could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here, and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct, but now the diagram, instead of looking like this, is going to change the not equal to equal equal, and we just need to make sure that we print out the right thing accordingly. And again here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who've been programming for years might not necessarily be in the best habit of indenting your code properly, and one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here, and indeed it needs to be indented and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts, and that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file, and I'm going to go ahead start by just getting the user's scores, again, on some assignment or test or the like, and I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100 percentage points. Now, how can I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how am I going to express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grade range. If
Okay, I don't understand. I mean, there's ways to change this, because this doesn't make any sense. Oh, no, no, no. It would be greater than or equal to 80. Really? What?
The score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways, and maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the students a B, if it's in the 80s. L if score is greater than or equal to 70, and the score is less than 80, I'm going to go ahead and give them a C. L if the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade.
Okay, this may just be because I'm old. Yeah, that's what's fucking me up here. But here in Canada, we don't. An A is 80 and above, and then it's a B, C, D, and then an F. Or at least it was back when I was in school. I know this is all going to change.
So that's the catch-all, and I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D, else it's going to assume that you got an F. Well, let's try just a few of these here. Let's run python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time, maybe it's a 95, still an A. Starting to slip further, so I got an 89 the next time, that's now, say, a B. And let's say I really had a bad week and it's now like a 71, that's now a C. Or I didn't even submit it at all, that's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong, it's correct. And indeed, according to my own specifications, I dare say this code is correct, but can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90, but I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score, and here 70 is less than or equal to score, and then lastly 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can encode in Python do this, which is just a little cleaner, right? It's tightening.
Okay. So we're saying that
faster to type, it's easier to read moving forward, so that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We can say something like, if the score is greater than or equal to 90, well, the student gets an A. L if the score is greater than or equal to 80, the student gets a B. L if score is greater than or equal to 70, they get a C. L if the score is greater than or equal to 60, they get a D, else they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong, or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else you know it's in the 70 to 79 range. Else it's in the next range down. So it's a minor optimization that allows us to ask fewer questions, but again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditional, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered, and even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60, and if I kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like you had before, the previous one that you had with the else?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. So let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. And mathematics parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too. So I just asked the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in mind. Terminal, and let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before this last one here, a percent sign, and it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0, because it divides cleanly. 4 divided by 3 has a remainder of 1, because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them what's x question mark. And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even, to be clear? A number like 0, 2, 4, 6, 8, 10, 12,
Easily divided by
14,
2.
16. Those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10.
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a code that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0, or is it 1? Do we have nothing left over, or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote-unquote even, and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer, so I'm going to go ahead and print out quote-unquote odd instead. And let's go ahead and now run python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own function. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd, and so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program, and I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark, and then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven, and I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote-unquote even. So if this magical function called isEven returns true as its return value, I am going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist, and the program would break if I ran it right now. But that's okay. I have the ability, recall, to invent my own function, so let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number, generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n%2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return
I wonder. Oh, it does do it.
what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of an infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n%2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and isEven, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more. What's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me that I can now use in this program and heck, maybe future programs that I write, I now have a function that no one gave me, I gave myself, that I can use and reuse. I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y, or y greater than x, or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's okay because I know, because I wrote it, that that function isEven returns true or it returns false, and that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now.
Oh my god. Yeah, don't pause, just
How
fucking
I've
go.
implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class, day before yesterday and Eureka. I have just one query, like based on my background of Java. There, when we used to pass the argument, we can also pass the address of the variable. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these is-evens?
So I actually had a question about defining a function, if that's okay. So if you define one, are you, like, within your code, like you made it up, are you allowed to use the dot operator like we did name dot strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string, for the examples you gave. I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip, you can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems, and in the Python community of programmers, there tend to be some ways that are smiled upon more than others, and they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++. If you've programmed before, and if you've never programmed before, this too is going to be new. Instead of asking a question like this, if, else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking, if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this. Return true if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience...
This looks like an arrow function.
You might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now, the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. And that's pretty darn close to something you might say logically in English, be it about even and odd or really anything else. So that program's going to work exactly the same. Python have parried it out high. Let me type in 2. It's still even. Let me type in 3. It's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0 or not? Like, that is by definition a Boolean expression. It has a yes-no answer, a true-false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct and still readable version of this code would be to delete this whole line, Pythonic though it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it does, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement this same idea. Now, which is better? This is pretty darn good. And it's hard to take fault with this because it's so very succinct. But it's perfectly okay and just as correct to have an if And then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name, and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, question mark. And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter, well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. If name equals, quote unquote, about Draco Malfoy in the books, let's go ahead and print out, quote unquote, Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who, question mark, just to convey that we don't actually have a hard-coded response to that particular.
Okay, let's take a moment and do this. Print. Ron, Draco. Oh man, this is tedious. I've never read the book, so I don't know anything about it. I saw the movies once.
Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And voila, we see that Harry is indeed in Gryffindor. Let's run it one more time, Python of house.py, let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter, and who, because we haven't actually hard-coded with an if condition in this case, what house Padma is meant to be in. Alright, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these 2 blocks of ifs, leaving just Harry's for a moment, and let's use that or keyword again and say or name equals quote unquote Hermione or name equals quote unquote Ron, thereby consolidating.
No, I think you can narrow that down by just like or removing the names.
And then the final else to catch anyone else. Alright, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She too is still in Gryffindor. Let me try it with Ron, and that too still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You could imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well, for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you can imagine that code was getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py, and let me propose that I get rid of my current if, else, approach, and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on, and then I'm going to go ahead and include a colon, and then underneath that, I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry, and I'm going to put Harry in quotes because it's a string or a stir, and I'm going to have another colon at the end of this line, and indented under that one, I'm going to go ahead and for now print out Gryffindor, which of course is Harry's house. Otherwise, I'm going to have another case for quote-unquote Hermione, and similarly, I'm going to have under that indented, print quote-unquote Gryffindor, close quotes. Now I'm going to have another case for Ron, also in quotes, with a colon, now print quote-unquote Gryffindor. And now I'm going to have another case for, let's say, Draco. This one gets a little more interesting because Draco, of course, now is in Slytherin. And then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window, running Python of house.py.
You need break, don't you?
He seems still to be in Gryffindor. Let's run it again for Hermione. Enter. Gryffindor. Let's skip ahead to Draco.
Oh,
Draco's
okay, it's fine.
Now let's try another name that we handled a case for, like Padma again. Enter. And we're just ignored. There's no output whatsoever because there wasn't a case for Padma. Now we could, of course, go back in and explicitly add one for Padma, but what if we, similarly to the else construct, just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that, using this new match statement, is to still have another case, but then to use this single underscore character, which is used in other contexts in Python, but for here, it's meant to say whatever case has not yet been handled, go ahead and print out, as we did before, for instance, quote-unquote who, with a question mark at the end. Now let's go ahead and rerun this. Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all in the same line in the same if statement, but here we have now 3 case statements again for all 3 of those. Well, we can tighten this code up as well, but the syntax is going to be a little bit different. I'm going to go ahead and delete these 2 middle cases for Hermione and Ron, and then up here next to Harry's name, before the colon, I'm going to go ahead and use a single vertical bar, and then a quote-unquote Hermione, then another single bar, and do quote-unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now, one final run of the program, with Python of house.py, let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor, and indeed, all 3 of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably, it has tightened things up. Arguably, it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place, but ultimately, this would be an equally correct approach to that same problem. But it turns out with the match statement, you can do even more powerful forms of matching as well. Here, we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement, as has been peppered throughout, and you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding some of these new keywords here, like if, and elif, and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it, and these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also these conditionals, but also next loops, the ability to do something now, again, and again.
Neat. Okay. Next we'll be doing the problem set and taking a look at the notes and stuff like that. But that's I gotta go.